How to determine the equation of a tangent to a curve. So for differential calculus grade 12 or for calculus grade 12 tutorials, we know that in the playlist, this is one of the tutorials that we are like working on. We're going to work on the equation of a tangent to a curve. Hi guys, Diva here from Bright Young Brains. So for a question like this one, right, this could roughly be 6 marks in an exam. 7 would be pushing it, but you know, it is what it is. So here we need to determine the equation of a tangent to the curve of f if the point of contact is where x is a -1. Now the big idea here with a question like this one is anytime you work out the equation of a tangent to a curve, you need to remember two main things. Now those two main things are a tangent and a curve have the same gradient at the point of contact. That's the first thing. The second thing is that a tangent and a curve share a coordinate. I know that's blunt because the coordinate that they share is the coordinate at the point of contact. You see, where they meet, they'll have the same coordinate. It sounds dull or weird or dumb or like a dumb moment for me to like say this, but then trust me, it's super important to keep these two things in mind because that's all you need to get 6 marks for a question like this one. So these two things here, we're going to use them over and over again in our question until we're done. So to start off, we need to keep in mind that anytime you are asked for a tangent is just a straight line. So if you're asked for a tangent, all you need to remember is that they're just asking for the equation of a straight line. So the first thing you want to do is to write out the standard form of the equation of a straight line. So the standard form of the equation of a straight line is just y is equal to mx plus c. So you having to have done this, it gives you the opportunity to see that you literally just need two things for this question. The two things that you need for this question are the gradient and the y-intercept. So we are going to work on getting the gradient first because that's usually the easiest one to get first. Always try and get the gradient first because that's like the chunk of the work. Now we are going to make use of point number 1. A tangent and a curve have the same gradient at the point of contact. So what I mean by that is this curve here, you want to get the gradient of this curve at this point of contact because the gradient of this curve at this point of contact is also the gradient of the tangent. So let's do that. Getting the gradient of this curve at this point, we need the gradient equation of this curve. Now the gradient equation of this curve, we get that by differentiating once. Before we differentiate though, we do need to simplify this here because we cannot differentiate it like this. This term here is fine. However, this one needs to be simplified. Now simplifying this, we just have to keep in mind that it has x down there on the denominator position and x has an exponent of +1. So what you want to do is this x to the power +1, you want to write it next to the 1/2 with this having a negative exponent. So that is going to look like that because all you need is you need to be able to see a coefficient, a base, and an exponent. If you can see those three things, you will always be able to use the power rule to differentiate. So here, our first derivative, we know that that is a gradient equation. So differentiating this, we know it's just 1 there times 2, and then the exponent there, we have to remove 1 from there. So that will just be x to the power of 0, of which x to the power of 0, we don't write it. So we just leave it out. This, we know it's -1 times the half there, which would give us a -1/2. And the -1 minus 1 is going to give you a -2 over there. Now here we're not, this is fine if you want to leave it like that. It will be okay to get you your gradient at -1. But as a way of forming good habits, always try and leave your exponents with positive values, or always try to leave your answers with exponents that are positive. It will help because, you know, habits. So here, what you want to do is the x to the power of -2, you want to take it under the 2 here, and then you want to write that with a positive exponent like that. So now you have differentiated, now you have your gradient equation. You could have used this 100% fine, you see, but we said we're trying to just formulate good habits. So we have to leave our answers with positive exponents. Now you have a gradient equation. And now this gradient equation can get you the gradient of the tangent, because a tangent and a curve have the same gradient at the point of contact. So here we need to work out the gradient where x is a -1. Working out the gradient where x is a -1, we just throw x into this equation. Throwing x into this equation, you just want to put all this into your calculator. So in our calculator, if we throw all this in there, we should get the positive 3/2. Now this is the gradient where x is a -1. So we have the gradient now. This is the gradient of the curve at -1. However, we know that the gradient of the curve is the same as the gradient of the tangent. I think you get it now. So far, we know that y is equal to 3/2x plus c. Now we need to find c. And the only thing stopping us from finding c is a coordinate that the tangent passes through, or a coordinate that our straight line passes through there. Now the good news is a tangent and a curve share a coordinate. So automatically we know that if this is the x value of contact, we know that for us to have like a full coordinate, all we need is to throw in our x value into this equation. Because you see this equation here, if you throw x in there, it's going to give you a y value, and then you have a full coordinate. Now that full coordinate for our curve is also a coordinate for our tangent, meaning we will be able to use it in this equation. You see, that's why this second point is important. So second point is important. So in our equation, let's throw -1 in there and get a coordinate. You see, we're using this -1 twice. Let's just do that. In our equation here, we can see that if you throw -1 into the original equation, remember, be careful. You see, we're throwing it into the original one. It looks a lot like this, but it's not. You see, if you throw it in there in your calculator, this should give you -5/2. And you see, these look alike, but it's not the same thing. This is gradient, this is a coordinate. You see, this is saying if the x value is a -1, the y value is a -2/5. This is saying at that same x value, the gradient is 3/2. So we have a coordinate which we can throw into our equation there. So in our equation, we know that where y is, we can throw -5/2 there. Where x is, we can throw a -1. Simplifying this, your value for c there is just going to be a -1, meaning that your full equation, y is equal to 3/2x minus 1. That's going to be your final answer. Now we know that getting the equation of a tangent to a curve can be asked in multiple ways. For more examples like this, you want to check out the differential calculus course, which is linked in the description. On the course platform, we go deep into different topics, so you definitely want to check that out. If this tutorial was helpful, be sure to give it a thumbs up, and for more tutorials like this, be sure to subscribe, and I will see you in that next tutorial that you will watch after you have subscribed. If you have not subscribed, hey, yeah, ne?